right? So minus 120 times 10 to the power 3, z minus 0.8, right? Then plus 160 times 10 to the power 3, z minus by 1.6, right? Then because we take our moment down here, anti-clockwise is positive, plus by moment as a function of z, the whole thing is equal to what? 0. Okay, so now you have to be really awake. Okay, minus 120 times 10 to the power 3 z plus 120 power 3 times 1.8 is equal to 96 times 10 to the power 3. Then plus by 160 times 10 to the power 3 z, and then minus 160 power 3 times 1.6. You got so much more component now. 256 times 10 to the power 3 plus by m as a function of z is equal to 0, right? So m as a function of z will be equal to 120 power 3 minus by 160 power 3 equal to minus 40 times 10 to the power 3 z. Okay, so minus 96 power 3 plus 256 power 3 is equal to plus by 160. Exactly the same. Okay, but you can see, right? The one on top, the first method I told you, you just have this expression over here for your moments. Over here, right? You look at your moment, you have so much more component coming in, and you have to ensure that this distance is correct. If you mess up with this distance, you are game over. So that's why it's necessary to learn, right, the analysis from left to right and right to left. Okay. Next, we are going to construct our shear force and bending moment diagram. Okay. And I'm going to have all this equation with us. Okay, so this is the equation we have, and then we are going to go on. Going to see what this work. Yeah, I can still read them. I'm fine with this. Okay, so from here we are going to plot our shear force and bending moment diagram. Okay, so we are going to have, undo. So this is our z direction, right? And 0. So I'm going to use 0.8, 0.8, 1.6, 2.4, 3.2, 3.2. After 3.2 is what? 4.0. Okay, 4.0. So that's our Z. Then we're going to draw our. So we are going to range from so 20, 40, 60, 80, minus 20, minus 40, minus 60. Okay, and this is our V, yeah, our shear force, and it is times 10 to the power 3 Newton. Okay, so we know the 2 points. This is your point A and your point D, both ended up in 0. Then you have a function of what? Minus 50 times 10 to the power 3 when between the limits of 0.8. Okay, so you will have minus 50 power 3 times by 0.8. You have minus 40. Okay, so this is where you have minus 40. And then from here, if you look at the function, is a first order polynomial, so it's a straight line. okay, coming down. And then at point B, okay, which is Z equal 0.8, it goes to positive 80. This is because we have a support. Okay, so we have a positive 80. Right, I'm going to stop here for a bit, and I'm going to draw the bending moment equation, or the bending moment just below it. Okay, I'm going to draw the bending moment just below it. I know some of you remember this, but some of you forget. This is a good time to do a revision on this. So again, this is my 0, 0.8, 1.6, 2.4, 3.2, 4.0. So this is our Z. And then we have our bending moment. Okay, I maybe have not enough space. I will push it down some more. Hopefully this is enough. Okay, so I'm gonna have 8, 16, 24, 32, 40, and 48, and this is our moment, and it is going to be in times 10 to the power 3 Newton meter, and you have -8, -16. Okay, so if you look at point B, right, your moment, so at point A is 0 down here, right? I think I will copy this and paste so you can see better. Right, and if you see over here, right, at point B is -16, right? So -16, right? And if you look at the polynomial equation, it is minus, right? The coefficient is minus, means it's set face. Okay, it's a curve, is set face. So you draw this set face. Okay, so this is where you get your -16 times 10 to the power 3. Okay, right. So the next one, then we go back to our shear force diagram again. And if you look at the function over here, right, it is a straight line. And you look at 3.2, it's at -40. So 3.2 is at -40. And then you draw a straight line. Okay, draw the straight line. And the straight line happen to intersect your z-axis at 2.4. Can you all see this? This is 2.4. So to check whether your function is correct, right, you have this -50 times 10 to the power 3 z plus by 120 times 10 to the power 3. You want it to be equal to 0, right? So z is equal to 120 times 10 to the power 3 divided by 50 times 10 to the power 3. So this is equal to what? 120 power 3 times by divided by 50 is equal to 2.4. So your equation is like spot on, right? Okay. Then I'll finish the shear force diagram. Then you go horizontal, right? You will go from horizontal from here to here, right? And then it goes vertical. So over here, I like to translate a few points. Okay, there are few important points that we need to know, right? So when I draw this line down here is where you have maximum shear stress, shear force, sorry. Then we also know that we have a 2.4 down here, right? And then another interesting point is the 3.2, because 3.2 onwards you have a negative 40 in the shear force. So I just draw this line. Okay. Right. So next I'm going to look at our bending moment equation. Okay. So our bending moment equation, right? So we're looking from 0.8 to 3.2, right? 0.8 to 3.2. So how this look like, we don't know yet. Okay, we don't know yet. So let me elaborate. We don't know yet, right? So if we look at the function now, if we were to look at the function m as a function of z is equal to minus 25 times 10 to the power 3 z squared plus by 120 times 10 to the power 3 z minus by 96 times 10 to the power 3, right? So we want to find dmz over dz, which is equal to 0. Why we are doing that? We want to see up to 3.2, did it continue to go up like this, or it achieved its maximum and there's a U-turn? Okay, so we just differentiate the equation. So when we differentiate, you have minus 50 times 10 to the power 3 z, right? Plus by 120 times 10 to the power 3, the whole thing will be equal to 0, right? After different. So z is equal to what? 120 times 10 to the power 3 divided by 50 times 10 to the power 3 is equal to what? 2.4. Right? So at 2.4, it reached its peak, right? Over here, we know that dm over dz is equal to what? 0. Okay. So when that's the case, you can find when m, right? When m is equal to 2.4, what is your moment? Okay, so minus 25 times 10 to the power 3 multiplied by 2.4 squared plus by 120 times 10 to the power 3 multiplied by 2.4 minus by 96 times 10 to the power 3, the whole thing is equal to 0. So this will be equal to minus 25 power 3 times by 2.4 times by 2.4 plus 120 power 3 times by 2.4 minus 96 power 3 is equal to 48 times 10 to the power 3 Newton meter. I know I'm over time. Give me like 3 more minutes. We're almost done with the bending moment diagram. Okay. So we know that this is at 48, right? And then at point C is at 32, right? So now we can draw, right? At point C is at 32. So now we can draw our curve. So our curve look like this. It will go up and then it will come down, right? And it's a set phase because the highest polynomial is negative. And then the last part is just a straight line coming down to 0. Okay. So this is how you construct your shear force and bending moment diagram. Go for a 5 minutes break. Later on, I'm going to summarize this, right? What is the relationship between the shear force and bending moment diagrams. Go for a 5 minutes break. We come back at 8:20.